Welcome back to the Surgeon Study Vault YouTube channel, where today we're asking a pretty massive question. Is teleportation actually moving out of science fiction and into hard fact? I am so thrilled you're here for this explainer, because what we're looking at today is literally going to shift how you view the world around you. Let's get right into it. Seriously, just think about that for a second. When we hear the word teleportation, our minds instantly go to sci-fi movies, right? Like beaming people onto a spaceship. But today, we're diving into a mind-bending new breakthrough in quantum physics that proves reality is stranger and honestly, way more fascinating than you could ever imagine. We are looking at a real, documented scientific achievement that is fundamentally changing our digital future. Here's our roadmap for today's explainer. 1. Welcome to quantum reality. 2. Superposition and entanglement explained. 3. The 270-meter quantum teleportation. 4. Building the quantum internet. And finally, 5. The battle for the universe.
Okay, kicking things off with Section 1. Welcome to quantum reality, the foundation of the microscopic universe.
Just as a quick refresher, since we're all fairly familiar with the weirdness of the microscopic world, quantum physics examines the absolute smallest elements out there, like electrons and photons. Down at that scale, classical rules just completely fall apart. We're talking about the fundamental building blocks of nature, whose strange, probabilistic rules act on literally every scale to give us a complete picture of reality. And what's truly wild is just how fast this field is moving. I mean, we've rapidly progressed from the old quantum theories popping up in the early 1900s to Einstein and his colleagues publishing early papers on quantum reality in 1935, all the way to a real 270-meter quantum teleportation achieved recently. In less than a century, we went from theoretical math on a chalkboard to actually beaming information across the sky. Absolutely incredible.
Moving on to Section 2. Superposition and entanglement explained, the spooky rules of the quantum realm.
To really wrap our heads around this recent breakthrough, we need to revisit wave-particle duality. In classical mechanics, things are totally predictable, right? A coin is fixed on heads or tails. But in quantum mechanics, elements exist in this weird blur of probabilities. They exist as a wave of multiple possibilities simultaneously, right up until the exact split second they're measured.
Which, of course, brings us to Schrödinger's famous 1935 thought experiment. You absolutely know the one. A theoretical cat in a sealed box is somehow simultaneously dead and alive in a state of superposition. It perfectly visualizes how the very act of observation itself is what forces the wave function to collapse into a single definite state. But here is the absolute secret sauce that makes teleportation possible: quantum entanglement. This is where interconnected states across multiple particles mean that changing the specific properties of one instantly shares that information with its entangled partner. And the crazy part? That happens regardless of physical distance. They could literally be light years apart. All right, let's get to the main event. Section 3, the 270-meter quantum teleportation, a stunning breakthrough in quantum networks. 270 meters. In a truly historic achievement published in Nature Communications, researchers from Paderborn University and Sapienza University of Rome successfully teleported the polarization state of a single photon across a 270-meter open-air link. Now, to be clear, they didn't beam a physical object like an apple across a room. They transferred the precise quantum properties of one photon to a completely independent photon over in another building. As you can guess, this was a decade in the making. First, they engineered these highly precise semiconductor quantum dots to generate entangled photon pairs. Then, they shot the signal through actual atmospheric turbulence using a GPS-synchronized free-space optical link. And finally, utilizing that entanglement we just talked about, they seamlessly transferred the exact state to a physically separated particle. And here is the really crucial point. They achieved an incredible teleportation state fidelity of 82%. Basically, that means the quality in which the quantum states were preserved during the teleportation was phenomenally high. In fact, it completely exceeds the classical limits of physics by more than 10 standard deviations. It's a massive proof of concept that long-term strategic planning in optical quantum technology is paying off in a huge way. So, on to Section 4, building the quantum internet, how teleportation changes our digital future. Now, you might be wondering, why should I care about photons and quantum dots? Well, because this successful teleportation is literally the vital missing piece we needed to build scalable quantum relays. And those relays? They are the backbone of a large-scale quantum internet.
We're talking about ultra-secure communication that is physically impossible to eavesdrop on without collapsing the quantum state. We're looking at unhackable quantum encryption keys, exponentially faster computing, and advanced data processing that's going to revolutionize everything from medicine to AI. Looking ahead, these researchers definitely aren't stopping at 270 meters. They are already plotting their next big milestone, achieving something called entanglement swapping between two deterministic quantum dots. If they can reliably produce these single photons on demand and swap their entanglement, they'll create the world's very first true quantum relay. That right there finalizes the blueprint for a highly secure, fully functional quantum communication network for the entire globe.
Which brings us to Section 5, the battle for the universe. Does nature have laws or just habits? As we aggressively push the boundaries of quantum teleportation, we're kind of forced to rethink reality itself. Theoretical physicist Lee Smolin proposes this mind-blowing idea called the principle of precedence. Instead of fixed, unchanging natural laws, Smolin hypothesizes that these quote-unquote laws actually emerge over time. When a quantum system is reproduced, it might just be copying past behavior of similar systems. So essentially, nature might not have strict laws at all. It might just have deeply ingrained habits.
And that leaves us with a pretty profound realization. If we're out here building the quantum internet by manipulating these emerging habit-based behaviors of particles, we really have to ask, is the universe itself still learning its own rules as we go? Are we, by observing and teleporting these photons, actually participating in the ongoing creation of reality? It's an incredibly wild concept to carry with you today. Thanks for watching. Follow Surgeon Study Vault for more content, and I'll catch you in the next explainer.